Welcome to the System Design and Management webinar series. The System Design and Management program is a mid-career master's degree program that's jointly offered by MIT's School of Engineering and the MIT Sloan School of Management. The System Design and Management program provides a systems thinking perspective that integrates management, technology, and social sciences to address rapidly accelerating complexity and change in today's global markets. Graduates earn a Master of Science degree in Engineering and Management. The SDM program also offers a one-year certificate in Systems and Product Development. We're pleased to have Ben Levitt present today on establishing a systems engineering organization. Ben is a consultant at Technology Strategy Partners. He has 15 years of systems engineering experience, including working at Raytheon as a technical product manager, systems engineering lead, product test lead, and systems algorithm engineer. As a graduate of the System Design and Management program, he has a Master of Science in Engineering and Management from MIT. He also has a Bachelor of Science in Industrial and Systems Engineering from Lehigh University. Ben will present for approximately 45 minutes, and then we'll open up the webinar for questions. Please use the chat feature on the webinar to ask questions, and we'll respond to as many as possible. Please join me in welcoming Ben Levitt for his talk today.
Thank you, Joan, and thank you to the SDM community for inviting me today, and thanks to everyone who's listening live and as a recording. So let's get started. So a little on my background. I started at Raytheon in 2004, and the experiences at Raytheon have really been the foundation for my career, from conceptual innovation in a think lab environment to architecting and managing missile defense products. My functional roles, if you on the chart, my functional roles are solid, and my sub roles are in the dotted line. As Joan mentioned, I was fortunate enough to attend MIT's SDM program from 2012 to 2014. After a short stint back at Raytheon, I joined a consultancy called Technology Strategy Partners as a means to apply skills and knowledge that I had learned in other domains. TSP is an industry leader in system architecture and product platforms, and here's a quick list of some of the industries that I've experienced at TSP. So the challenge. New technologies, big data, and the demand for customization have made system integration increasingly difficult. So here's a diagram of the rise in lines of code in Ford vehicles. So you can see that in quite a short period of time, that's 4x growth right there. At the 2016 CES conference, Ford indicated that the number of lines in the new F-150 is actually 150 million lines of code. That's quite a lot for a machine that arguably requires zero code to function. So within industry, I've seen more and more companies ask, how do I implement system engineering to combat and control this increase in complexity? And system engineering in this context focuses on how to design and manage complex systems over their life cycles. Historically, system engineering has been most successfully employed in organizations such as NASA and the Department of Defense, which provide overall guidance for robust, very long and expensive multi-year projects. Unfortunately, commercial businesses face time-to-market pressures and are typically on their own for guidance. Today, we're going to delve into industry benchmarking that I did to determine how the best firms employ system engineering capabilities and deliver them to organizations. And I'd like to point out that this isn't research. This is a study based on public information. Okay, so let's take a time machine back to 2005. So Steve Jobs introduces the first iPhone, a joint venture from Motorola and Apple. This is the first phone that utilizes iTunes, the iTunes interface on a mobile device. Steve calls it the iTunes phone. So how many people remember this phone? And I'm kind of setting you up here. So to give you a little reminder, Steve's on stage at the keynotes event in 2005, and he's listening to the Black Eyed Peas' Let's Get It Started when he receives a phone call. Steve picks up the call, hangs up, and he expects the music to come back on, but it does not. So it's an amazing idea, right? So how did we get here? Steve Jobs calls Ed Zander to congratulate him on being named the CEO of Motorola. Steve and Ed conjure up this cool venture idea. Let's combine two of the best consumer products on the market. So we have the iPod and the Motorola Razr. Everyone remembers that phone. So as soon as they start developing, it's already being held up, and it's late. So you can see January, February, March, April. And the rockers finally released by Singular in September 2005. Singular is now AT&T for context. All the while, Apple's been hedging their bet, and they've been developing the iPod Nano, which is arguably better. So it's that super slim iPod actually has more capacity than the rocker. So, while I'm talking about this, is that the misunderstood systems and interfaces really come out on troubled projects. So the rocker cannot download songs using a cellular connection. And that's not a blame on the engineers. That wasn't a technical issue. That was a corporate strategy mistake, which presented itself in the interface. Apple had clear incentives to not allow that interface to exist, even at a loss to the user experience. And typically we don't think of Apple that way, but in this case, they didn't want to cannibalize the iPod or lose any digital music rights. And this decision also conflicted with the incentives of the carriers who wanted to benefit from high data traffic. But that wasn't the only issue. The other issue was that the actual data interface wasn't great either. And I'll read this comment here that I found which still exists on Apple's website on the community page. Before the patch, it took an hour to upload 5 songs. Also, it deleted all the songs on my phone. To make it worse, I finally got around to loading 60 songs on my phone because I left it connected to iTunes overnight for 2 nights in a row, and then it started to re-update again when I needed to leave the house, leaving me with no other choice than to eject. Now I have 20 songs again. And it's ironic because the rocker really was the precursor to the iPhone, which started the whole smartphone boom. So it's interesting because I don't think of Apple that way, but these misunderstood systems really can motivate taking a different look at your company. And that kind of leads us to rationale for system engineering investment. So the number one reason for a company to invest in system engineering is past failed projects. Some of these are very public, like the Galaxy Note 7 with the battery issue, some of SpaceX early failures, and there's numerous military and aerospace mishaps. And this also includes projects that have been constantly delayed. Like in the news lately is the Tesla Model 3 because it's so public and everyone's so excited for it. But there's also a lot of less popular items that have been delayed, including Navy destroyers and quite a few other type of big industrial products. Another reason is integration of new technologies. So I see it in my daily life. We all kind of feel like autonomous cars are coming, and home IoT is everywhere. And from a bigger perspective, IoT is now spanning into factories to increase efficiencies as well as to improve maintenance. We also see Amazon Robotics building robotic arms and pickers to make everyone's life easier with Amazon Prime. Risk mitigation is another big reason, and it's typically the reason that people think of when they think of system engineering. Risk mitigation is often like priority of management when they think about process, system engineering, and how we can de-risk our complex devices. And the final one isn't increased complexity to deliver customized products due to managing more configurations. There's some really good examples here, and BMW is one of them. BMW has been able to increase their variety, as well as increase their revenue and their delivery times, while keeping the same number of engineers by building architectures that are able to manage multiple configurations. We also see this in oil and gas cases, especially in upstream oil and gas. So these rationales led me to 7 investment areas that are listed here on the right. And we're going to unpack each one with benchmarks in the next slide. So, benchmarks for each one of these investment areas. We're going to start at the 1 o'clock there with corporate strategy. And when I say corporate strategy, I mean system engineering enabling corporate strategy objectives. Google is a great example here, as they have succeeded at transforming innovative prototypes into products that Google will continue to explore and continue to improve even while mass users beta test their products. It's a great strategy, and we all are really benefiting from that. All of us Google users are. The second one here is roles that set up creative tension. So Apple, one of the most famous companies in the world, they understand that adding system engineering philosophies is important to build complex systems. Apple builds this creative tension by employing system engineering program managers on each product team. They kind of function like a project manager, but they focus on SE. I've also seen this tension be set up by system architects who kind of play between the marketing side as well as the engineering side while they're building their architectures. And when I say architectures, I mean system architectures. They're kind of playing that tension role, and they're not really giving to each side. Empowering system engineering leadership. So this represents a culture of system engineering that encompasses both technical and leadership aspects, including how system leads can control project progression, as well as be the voice for customer needs, and make sure that the customer need is met with validation. And I found that defense companies are often the best bet at implementing this benchmark. Fundamentals is typically what people think of system engineering. I would call it the basics of system engineering. And it's what system engineering training is mostly focused on. This is requirements, this is emergent properties, verification and validation, as well as process management. Architectures that meet corporate goals. So these are system architectures that are clearly articulated to meet a particular corporate vision. So BMW does that as the example I just gave, and SpaceX is another great example of that. And we're actually going to go into that example a little bit more further in this presentation. Analysis for great products. So these are firms that concept and innovate as a source of competitive advantage. They identify and manage system trades, and they use data analysis to innovate their products. And what's interesting, as I said before, this is all kind of based on public information, and everything here is sourced, but it's very difficult to find. Companies don't like to give this away. That's one of those ones that they like to keep close to their chest because that's important, and that's how they get their competitive advantage. 2 published cases here are Pratt & Whitney and Intel, which both have used design system matrices to explore their products. I'd also include Johnny Ive's renowned prototyping analysis process at Apple as a very good example here. And the final one is tools and workflow that enable system engineering analysis. So this is life cycle management with data. Often what we see here would be model-based system engineering, also called MBSC. And NASA's Jet Propulsion Lab is well known for this. And this is one of the capabilities that we're going to explore a little bit later in this presentation in more detail. So typically when someone hears system engineering, they think of system engineering, they think process and they think rigor. And that's what I've kind of felt throughout my career. But when I peel the onion another layer around those capabilities that we just talked about, around those investment areas and those capabilities that we just talked about, I find a lot more. I found a lot more capabilities, and they're listed here. But what I really want to focus on here is the results. So new products and features with less risk. And to get those results, the box right below, system behaviors, is kind of what I want to focus on. So those are the things that you're doing everything around it to get those behaviors. And that's kind of what I felt. That's things I've seen. And this diagram almost acts as a takeaway from the study that I conducted on things that I've seen and what I've found out there on system engineering. And another takeaway here is that there are many different capabilities delivered by system engineering. So as I mentioned before, I spent a formidable amount of my career at Raytheon in system engineering. A mentor of mine at Raytheon was Dr. EllenFerraro. She's a director of System Architecture Design and Integration Directorate. Ellen may look familiar. She presented at the 2012 MIT System Thinking Conference. When I was looking for ideas for my MIT thesis, my graduate thesis subject, I reached out to Ellen. She told me to meet her in a parking lot at one of our facilities to meet with a small innovation team that was testing out a new low-cost, high-powered radar. This team had a solid technical design, but needed more product management, how they were going to implement and market this system, which was very different than a typical Raytheon big DoD system. And two things really struck me about that. Well, first, that the director of system engineering was setting time aside in her schedule to meet with a small team that was clearly not driving the company's profit and losses. And number two, that Ellen and her directorate scope is much larger than what most people consider system engineering. In fact, like Raytheon's engineering community is comprised of over 60%. The system engineering community is comprised of over 60% of the full engineering community. Raytheon's kind of created a very powerful system engineering culture, which includes high growth potential for accomplished system engineers, in so much that when you see chief engineers, they're often from system engineering. They've empowered system engineers and given them control over process and product. SpaceX is a really interesting company to me. Not because what they're accomplishing, which is amazing, but kind of why they're doing it. SpaceX's corporate strategy is to gain market share by undercutting their competition, specifically ULA, which is the United Launch Alliance, which is a joint venture from Boeing and Lockheed Martin. In 2004, at a congressional session, Elon Musk set SpaceX's kind of dollar per weight goal at $500 per pound of bringing product into space, which was besting the current metric by ULA by 10x. So it's interesting, and it's how's a company going to do that in a market that's been dominated for so long by these giants? And it really hits on SpaceX's corporate goal. But how did they do it? So they got creative. SpaceX initially used a type of should-cost method to redesign many aspects of kind of known rocket technologies for their Falcon 1, which was their first rocket. A friend of mine was actually responsible for redesigning one of those important parts of the rocket, the gimbal actuator. In his words, it's like holding a pencil in your hand, keeping a pencil straight in your hand while you hold it. He actually accomplished the price goal of that Elon set and met, and so he bested his redesign cost less than 5% of the current market price for that product. And that's great, and they got very far doing that. But that wasn't enough. SpaceX still couldn't meet their goals, that initial goal that they had. So what did they do? They disrupted the market again by changing their architecture so they could land boosters, thus reusing rockets to get their costs closer to that goal. And I think they've actually met the goal. They're very close to it now. It's impressive. And then Elon tweets this, which is even more impressive. So tools and workflow that enable system engineering analysis. When I think of this, I think of model-based system engineering, as I noted before. And I've seen these tools in my life as an engineer. And when I say model-based system engineering, I kind of want to hit on the popular technique, which is to use a model as a technical baseline, and it's intended to encompass the entire development lifecycle, which is important to note. And I've seen exceptional models work and play big roles in programs, but on the other hand, I've seen models, really good models, fail to sustain through design to verification and validation, which is arguably the biggest benefit of these models. And so as mentioned, NASA's JPL lab is a leader in this field. And if you're interested in this topic, I'd recommend reviewing their public information on BSC. There's quite a lot out there. When I was going through it, there was 2 lessons learned that hit me the hardest, and I've listed them here. Number 1 was investment is crucial. And number 2 was that management must be willing to pay the startup costs, and I'd argue also maintenance costs, and give time for efforts to pay dividends. And that's kind of some of the failure modes that I saw, was that you could invest in something and work it and drive it for so long, but you might not get the benefit if it wasn't maintained through the design process. So how do these leading firms deliver system engineering? So I find the answer to be a balance between system engineering control and organization structure. So looking at this chart, this diagram, on the x-axis, we have the corporate structure, decentralized versus centralized. And the y-axis, we have system engineering control, high control versus low control. Interestingly enough, I've seen that many firms want to jump straight to command and control organizations. So that's that top right corner, that's high control, that's a very centralized organization. That's essentially the NASA, the DoD, the Raytheon model, without considering other options. Moving to the left, that's high system engineering control, high project control, and a decentralized organization. So that's kind of like system project managers using systems tools on a project team without any centralized system engineering authority. If we traverse in the diagonal there, we're going to see low control in a centralized organization. So that's kind of an expert group. That's a systems experts group. That's a centralized group of experts that disseminate systems philosophies, corporate visions. There's some publications on GE trying this, as well as a few other organizations. And in the bottom left corner, we have low control in a decentralized organization. So that's that's more of a service organization. So that's delivering solutions outside of business units, outside of major profit and loss projects, but through system engineering principles. Shell TechWorks is well known for this, and I would say the industry leader that's public about it, that they've been able kind of to work a skunkworks outside, but still using system engineering tools with more of a pull from business units. So the business units will pull for certain projects, and Shell has seen that it worked very well for them. So aligning key capabilities in delivery methods allows me to key on how organizations with a systems knowledge base and a variety of different key capabilities can best implement system engineering. So how would a company establish system engineering organization? So I'm going to argue that there's three major facets. They need to focus on the key capabilities that an organization needs for a competitive advantage. The delivery method that they choose should be guided based on the structure of that particular organization. And the organizational action is then based on a direct capability and a delivery that will bring value to the organization and really a competitive advantage. I don't think I have to tell anyone, as you kind of see as we go through these slides, system engineering is probably not inexpensive. It is investment here, and I'd argue that it should really be connected to a competitive advantage to make an impact. While it may be easy to embrace one method or another based on kind of the perceived values of those benchmark firms that we talked about earlier, it's really those value-added competitive advantage capabilities that really should be a company's focus. So it's interesting to me, as someone who's into this, to see how other industries use system engineering to make their processes more efficient and gain a competitive advantage. These are some of the companies and technologies and industries that interest me most on this topic. To go around here, so autonomous cars, I talk about autonomous cars too much. There's Google's Waymo, there's kind of what Tesla's done, and a lot of other startups in that space. In robotics, I'm sure a lot of people have seen the Boston Dynamic robot dogs, opening doors, walking around. It went viral a few months ago when I first started putting these slides together, and there was a lot on Twitter and Instagram about the world ending when people saw these robots. It is amazing technologies. The next one to the right is C3 IoT, which is doing great things in integrating IoT in many different industries. As we go back to the other side, you can see the Shell oil and gas platform. Shell's done very well in that tech work space that we mentioned before, but also as driving system engineering throughout their company. The one in the middle is Intel's Core i9 chip, their brand new chip. To the right is healthcare. So how system engineering can help fix healthcare. That's a Harvard Business Review article. So it's definitely getting attention. The next one is the food system app. And to me, I find food and nutrition very interesting, and the idea of system engineering and system thinking and that holistic approach to that is very interesting. The next one over is biofuel. And the picture here is of Low C Controls, which is an STM founded company, or a STM grad founded the company, I should say. And then the final one is the Amazon EC2 cloud, one of the most powerful clouds out there. So along with my system engineering experience, there are several publications that I have read that have helped me frame my views on the discipline and how it should be delivered. The takeaway kind of here is that system engineering is a combination of several capabilities. So the knowledge of these aspects is going to be in a collection of sources. There really isn't one place to find everything, as there isn't one company that's doing everything. So that's all I have today. I want to thank everyone for their time. Here's my email, LinkedIn. Reach me however you'd like. I think we're going to do some questions, Q&A now. I could even start the Q&A myself and ask the community, how do companies grow system engineers? Is that through career? Is that through training? Is that through rotations? It's an interesting topic that I didn't approach here, but it's interesting one. I figured I'd start with the questions.
So, Ben, I may have you answer that. At this point, I don't have questions, but I do want to encourage those that are listening to please use that chat feature to add questions in. Usually, Ben, they come towards the end, so I do expect that we'll get some. But do you want to answer your own question you just posed?
Yeah, so I think it's a combination of those. I didn't mean to jump the gun there. I should have waited.
No, we're good.
So I think it's through a lot. I think there is some training aspects for sure. I think the fundamentals are really important. I think system architecture is really important. But I think the idea of incentivizing engineers to rotate through many different functions. I saw a lot of that at Raytheon, where Raytheon would try to incentivize engineers, even within systems, to move around and see different functions and different capabilities that are being worked to grow as engineers. It's hard to become a system engineer. It's hard to have a holistical point of view on things when you are just in one role. It's very difficult.
So I have a question for you. I know at many organizations, systems engineers cross boundaries between departments. And that ends up being a big challenge between where your hierarchical reporting structure is and where your responsibilities are versus the need to be able to make sure the systems portion is taken care of. Do you have any recommendations for organizations on how to think about that and how to set up potentially reporting structures to be able to manage so that system engineering is effective and not siloed?
Yeah, I think that's a really interesting topic. And I was trying to hit on that a little bit on the MBSC, where one department or one directorate may start it, but another director or department is actually receiving the benefit. And it's very conflicting incentives there of how do you split that? How do you split who pays for that?
Right.
Whose engineers, whose FTEs who should be working on those projects? And that's where things get very difficult. So I'd say that's a very difficult question to answer, and should be based on incentivizing both department managers in that case or directorates to work together based on who's receiving the benefit. And I assume that the department who's receiving the most benefit should be paying a little bit more. And we see a lot of that when you're trying to manage multiple configurations of products. Incentives need to be aligned, otherwise it becomes a failure mode.
So I have a question here. How do you see the application of machine intelligence, AI, machine learning in systems engineering processes?
Yeah, so I think that's a huge reason. I think that's a huge topic, and I think that's one of the key rationales that firms are starting to look more into system engineering because AI is so encompassing. On the slide where I had Rationale, new tech, and I should have had AI down. I had IoT for sure, but AI is one of those technologies that can really change an entire system, and that should really be. If you're adding AI to a system, you should really think about which capabilities you're trying to drive to, and focus on that. But I believe that is a big rationale for companies looking at system engineering.
So I have a question here. Are you aware of any training materials, templates, or case examples that could help in setting up systems engineering organizations?
There's a lot out there. I try to hit on some of the books there. Yeah, I guess reach out to me, and I'd be happy to provide everything I have on the subject. How I see system engineering as kind of 7 basic capabilities. It's dependent on what capabilities you're trying to bring, as I keep saying, but I would focus on that area, and there are definitely sources in each one of those capabilities. There's definitely open source stuff as well for more research and investment.
This is a message from an individual who's part of a news-based venture. So I'm trying to introduce systems engineering to my organization. My question is, how do I deal with managers who by nature can't capture the SIE ideas?
I love that idea of bringing system engineers into news organizations as the whole idea of news is supposed to be holistic and kind of see all different sides. I would send them a copy of this, the recording of this. From my perspective, I'd want to, if I was talking to a manager, I'd want to show kind of the value that system engineering could bring to a particular practice. And that doesn't have to be in kind of return on investment, or it just has to be in capabilities. And this is what I want. This, if we kind of explore this, maybe we can build in a different way, or we may be able to kind of find a competitive advantage against different types of news avenues like blogs or newspapers or Facebook.
Another question. Do you have any recommendations for how a small company, and it defines it here as less than 20 employees, can start to implement systems engineering?
Yeah, that's a great question. And some of this work was based on questions just like that. So I believe that companies should focus on the capability that they need to bring and then match that to the delivery model that best fits that company. So if it's a small company, you can have a little bit more wiggle room, but you're probably not going to have this you're probably not going to build a very centralized, powerful system engineering. You're instead going to bring in some capabilities that you can see would impact your current product and de-risk future potential problems and that nature.
I have another question here. In your experience and studies, how much have the intangible attributes of organizations, such as culture, affected effectiveness of systems engineering? Are there any best practice models?
Culture is very important. And I mentioned the Raytheon example that I experienced where system engineering was the culture. And I feel like Raytheon spent a lot of time, a lot of effort trying to become a system integrator for defense products by using system engineering. I think that should be the goal of every firm that has system engineering, that there should be their culture. I would look at SpaceX in that example, where they've kind of said, everyone's a system engineer here. This is our culture. We will review every decision kind of based on a holistical way. And they've somehow come up with a way to do that in a very fast method. But I would look on some of there is some publication by SpaceX on that topic.
This was a follow-up question from one of the earlier ones. Which systems engineering standard or standards do you recommend?
So that's a tough question. I don't recommend any system engineering standards. I would say the standards, there are quite a few, I guess, fundamentals, and I'd recommend those is a good place to start. So that's requirement management, verification, validation, and you can find that stuff in quite a few system engineering kind of like textbooks or training materials. And that's a great place to start. But I've tried to make the point that there's a lot of other topics around system engineering that's really important. When I think of standards, it's an interesting question, because there are a lot of standards and a lot of people perceive system engineering as a very rigid process, and I'd make the argument that there's more to that. It should be really connected to where the company wants to go. The defense-oriented NASA type principles and standards may not fit a startup or a small company, as a previous question hit on. Those are going to be time-consuming. Those are going to be quite robust, and those aren't going to really help time and market pressures. One of the goals here, and one of the reasons to investigate these type of topics and see what's really out there, was that a lot of the guidance out there is based on that NASA model, that original NASA model, which NASA started creating with a few, once they started realizing how big and complex their programs were, that they were doing something that no one's ever done before, and they were having failures. unless you're doing something similar to that, and SpaceX and companies like that may argue that you don't actually even have to go all that full way down those system engineering principles. I'd suggest focusing on things that really are going to drive your competitive advantage as a firm, and not so much kind of standard principles that are out there.
So the next question here, on your list of organizational actions to implement SE, are there any which are easier, cheaper, or lower risk? We're interested in applying SE in Japan, but it's a new concept here.
That's a great question. And that chart, that framework slide, is really supposed to be an example about how would one connect. I would say it's not prescriptive. So it's an example of how a firm would connect capabilities that they decided were very important for them to a delivery method, and then to an action. So I would suggest stepping through that. I can't, without knowing more, it would be very difficult for me to say which ones are more expensive, which ones are not. But kind of stepping through that kind of framework where you focus in on what capability do we need the most of, and then think of delivery methods. And that delivery method may very well come down to budgets and schedule, as well as culture and corporate structure. And from there, you would pick an action based on those two. But I would for surely start with what capability am I trying to build within my company before I jump to, before I try to frame it into I would say like a cost budget.
Can you provide your thoughts on how the recent focus on cybersecurity has or will shape or change the way you approach SE?
Oh, I love that question. I feel like cybersecurity is one of the biggest trends. It may be even, while it's not as in the news as much as AI and autonomous robots, it may be even more important as something needs to control those and keep them safe. I feel like more firms will start looking at system engineering because of with cybersecurity in mind. I feel like as I try to explain with that Ford diagram, how many lines of code Ford was putting in their new truck. It really begs the question on if there's that much code and that much complexity inside just a Ford F-150. Who's going to secure that? And I feel like that is a major rationale. I think system engineering will be used in more and more to factor into cybersecurity. I don't exactly know what method it would be used in or how it would be, but I'd imagine that will be a rationale for thinking more holistically about your system, and I imagine architecture will be a big one that will be hit by cybersecurity. You'll be trying to architect systems that are safe instead of architecting systems for different reasons.
Can you provide any examples of combining systems engineering with Agile beyond SpaceX?
SpaceX is a good example of that. There's quite a lot of firms that are moving to Agile now, in software and in hardware. I know Raytheon has done work in that. When I think people think of Raytheon, they think of a big defense company, but they've done a lot of work trying to move their projects into a more agile methodology. I would also look at kind of Apple. A lot of and we could probably just name companies just off any list of which companies are trying to use more agile processes and who are trying to iterate as fast as they can. SpaceX is a good one because they're very public about their processes, and there's been some great presentations on it. If there's a lot out there just in the public space on companies that are using system engineering and Agile with Agile methods. I kind of implore you to look at those. I don't have any companies that I could name on the top of my head on that subject.
In the next question, he comments that he's got limited time with executives to make the case for funding SE. What data from your presentation do you think might resonate as a good starting point for approaching executives towards SE investment?
So if I was making a pitch to executives, I focus on which capabilities are going to drive our firm to a competitive advantage against a competitor. I would show that, and I'd also show in terms of return on investment or increased revenue. Are we de-risking our items so that we're going to have less failures in the future, or are we creating systems to actually grow revenue and get more customers? Are we making our products more customizable, which would grow revenue, or are we kind of de-risking things, which may not grow revenue immediately, but will improve our brand? I talk more to that, but I also focus on which capabilities that I thought were most important here. And I feel like from an executive point of view, they typically want to see what's the next step, where are you taking this, and that's what I'd suggest.
So the next comment actually is less of a question, it's more just information to go out to the audience, and I just would like you to touch base on your chat if you're looking for the address here, and it just says, regarding systems engineering training, INCOSE has a number of training resources free to its members. This individual is the chair of the training working group, and he offers for others to contact him if they want to understand how to get at those resources. And so the email is john.clark@incose.org, but it's there on your chat box if you'd like it. The last question that I have here.
Thanks, John, for that. And I added the INCOSE was one of the first books I listed as a source for continued learning on this subject.
Absolutely. So I do want to say, I'm going to read you the last question, but if there's anybody else that has questions here, please feel free to add them in. So this one says, I've got a question on SE return on investment. The INCOSE handbook mentions a generic 15% program cost as an optimum SE effort. Do you know if this might vary by the industry type? For example, if service is different from product?
There is one resource on that. There is if you shoot me an email, I'll send you a link to it. I don't have it on the top of my head right now, but there was a study done based on return on investment. What is the right amount to invest in system engineering? There was a study done a little while ago, and I believe it's the only study I've seen on the subject. That those numbers sound about right, but that there's a diagram and a chart on it, so it may vary based on size of project. But speaking from a service industry, I don't know if there's been a study on that. You could probably gauge where the 15 to 20% came from, and then try to think about what makes the service industry different than kind of a typical system engineering fundamentals type organization, command and control, which is probably where those numbers came from, and kind of step back from there. That's how I'd approach that.
Do you believe that a dedicated group focused specifically on systems engineering could be more impactful than a combined component design / SE group? That is, could being too close to component design hinder the SE aspect?
I don't agree with that. From what I've seen, all four of the models that I've delivery methods that I've listed are all impactful. I think it's based on what you intend to bring. Where's that value coming from? I understand the point of kind of having system engineering kind of on the side so they can offer almost like a consultancy type point of view, like an outside point of view, and not feel that pressure from schedule and from program management. But on the other hand, having a strong person in that product team may actually have more influence. So more influence for certain types of capabilities. So I'd have a hard time saying one is better than another without kind of exploring the entire case. I think there's there's good reason to do each one of those different delivery methods, and it should be kind of based on where that company sits. I think you could imagine if the corporate structure and culture was not aligned for that, or was aligned towards a different method, that a different method may be better. It's very hard to be kind of prescriptive, as a question kind of asked, without really understanding the full scope of what you're trying to bring and what that culture what that culture and organization is currently at, and where it wants to go to.
So I have a follow-up question
All right.
that ties into that, and it says, would it be better to have a specialized SE group acting on different projects, or an SE person on each of the project teams?
Yeah, so it's a similar question. It's very difficult to be prescriptive there. Those both methods, both delivery methods have pluses and minuses. From what I've seen and read about and spoken to others about, outside of just my own experiences, there's both delivery methods work in the right environment with the right culture. It's a lot depends on what capabilities you're trying to bring. If you're trying to bring, for instance, fundamentals, that might be difficult to bring if it's just one person on a product team. But if you're trying to bring a different piece of it, if it's an architecture type, maybe you could work it that way. I can't really give prescriptive advice without knowing more, but I love the question.
So I just have one more follow-up comment to an earlier question, and then we'll wrap it up for the afternoon. This individual is Mohammed Salih, and he says, regarding your comment about news as a system, I wrote an article about it, and I'll send it to you. Others who are interested, send me an email, and if you take a look at the chat box here, it does have his email address for a follow-up on that if you're interested in Mohammed's article there.
Thank you, Mohammed. I love it. Thank you very much for the question and the kind of that outside perspective. We're talking to all these big engineering firms who's bringing in news. I absolutely love it.
So I do want to encourage you, up on the screen right now is Ben's email address, and there's one both at his work at Technology Strategy Partners as well as his MIT Sloan email address. And so if you do have any follow-up questions, please feel free to reach out to Ben for anything for follow-up. I want to give a huge thank you to Ben for coming in. It's always fantastic to see alumni come back and hear a little bit more about how you're applying and utilizing some of the things that we embrace here within the SDM program, and it's always great to welcome you back and hear from you. I also want to take just a moment before we sign off today to just give you a heads up that we actually have an additional webinar that'll be happening on Friday. And this is going to be by Eric Rebentish, who is a PhD researcher with the MIT Consortium for Engineering Program Excellence. Dr. George Roth, a research scientist at the MIT Institute for Data Systems and Society, and Victor Tang, Dr. Victor Tang, who was a former VP of IBM in China. And they're going to be speaking about turning strategy into results. They're actually giving a little bit of a preview for a conference that's going to be coming up that you should see on your screen right now that MIT SDM is hosting with support from the Brightline Initiative, entitled Characterizing the Gap Between Strategy and Implementation. That'll be here on the MIT campus on April 30th and May 1st. And on that slide that's up in front of you, you can see the further information slide, which is www.sdm2018symposium.org. I encourage you to check it out if you're interested in looking a little bit further at strategy and implementation. So with that, thank you very much, Ben. Thank you for joining us today.
Thank you very much. Thanks for everyone who's listening.